Hi, welcome to my video, Maximum Minimum Word Problems, Part 1. Part 1, I will provide you in this video with the word problems, and you just pick out the vertex, the time and the height, or the horizontal distance, whatever. And then there's more videos to come explaining how to derive the equations. Number 1, the path of an object fired into the air is presented by h of t, where equals negative 4.9 t squared plus 39.2 t plus 44.1, where h is the height in meters and t is the time in seconds. When does the object reach its maximum height? So the maximum height is, the vertex is, we have a t, which is the x, treated as the x, and we have the h. So the vertex is t and h. That's very similar to y equals ax squared plus bx plus c, where we have a vertex of x and y. So the vertex, so to get the vertex, which is, instead of x, we say t is equal to negative b over 2a. That means a is negative 4.9, b is 39.2, and c is 44.1. So to get the time, negative b, so it's the negative of b is 39.2. Write that down. And it's 2 times a, which is a negative 4.9. And that gives us a negative 39.2 all over negative 9.8. And if you divide that with a calculator, you will get 4. And time is in seconds, so we have 4 seconds. It takes 4 seconds to reach its height. If we look at the problem, and height is in turn as a function of time, let's draw a little diagram to see what happens if you have the height is 0. Sorry, if the time is 0, this becomes 0, and this becomes 0, so the height is 40.1. So 40.1 meters, this is time, and this is height. So at 0 time, the height is 44.1. So the object is thrown from this height, goes up, and it comes down, and it hits the ground. So 4 seconds is 1, 2, 3, 4. 4 seconds is right there, and that's the time, or what we call the x-coordinate of the vertex, 4 seconds. So what is the maximum height when the time is 4 seconds? So what we do, we take the h of 4 seconds, t is 4 seconds, and we sub it into the equation. 4 seconds, 4 squared, 39.2. T is 4 seconds plus 44.1. Now, what I do, I take my calculator, and I'm going to move this page up a bit so you can see what I have done, and place my calculator here. So what I have is, turn on my calculator, and I have a negative 4.9. Notice the negative button. This is negative 4.9 bracket 4 bracket squared plus 39.2 bracket 4 bracket plus 44.1, and if I hit enter on the calculator, I'll get 122.5. So move the calculator away, and when I work all that out, if you want, you could work out each individual part and do it all, but it comes out to be, in the end, 122.5, and the height is in meters. So you could work them out individually and, you know, work what this is and work what this is and add them up, and you get 122.5. You can work each of these out with your calculator. So notice that's 122.5 is the height at 4 seconds. Okay, Number 2, a soccer ball is kicked from a spot on the ground towards the net, takes the path of h equals negative 2 over 45 d squared plus 4 over 3d, where h is the height above the ground in feet and d is the horizontal distance from the spot on the ground to the net. Okay, here we go. So if we think about it, it says find the maximum height. So what we have, again, let's think about it this way. We have a soccer ball, let's say this is the ground, and we have a soccer ball that's kicked up, and then the soccer ball comes down. So if you think about it, that position right there is this is D, which is the horizontal distance, and this is the height. So this is the vertex right here. So if we do D, notice is y equals ax squared plus bx plus c. So the vertex has a D and an h. So D equals negative b over 2a. And what we have, a is negative 2 over 45, b is 4 over 3. So we have a negative 4 over 3 divided by 2 times a, which is a negative 2 over 45. So let's simplify the numerator. We get a negative of that as a negative 4 over 3. And 2 over 1 times negative 2 over 45 gives us a negative 4 over 45. And what happens when we divide fractions? Whoops, let's make that a 4. When we divide fractions, we multiply by the reciprocal. So negative 4 over 3 times, flip that upside, 45 times negative 4. And we cancel, the negative 4's cancel. And 3 into 45 goes 15, so we get 15. And notice D is the horizontal distance. That's the distance that's to the net, and we got the height is in feet, and we could say the distance is in feet. Okay, so what happens is that we want, that's the horizontal distance. So from here, it's 15 feet out. It's going to be a certain height. And let's get that height. So we'll sub in h, negative 2 over 45. D is 15 feet squared plus 4 over 3 times 15. And we take our time, that's negative 2 over 45. 15 squared is 225 plus 4 over 3 times 15. Notice I squared the 15 first. Now I'm multiplying. So 45 divides into 225. We'd say that goes, let's see, 5 times? Yes. 225 divided by 45 is 5, and negative 2 times 5 is negative 10. 3 into 15 goes 5, so 4 5s are 20. Negative 10 and 20 is 10. And so it's 10 feet high, so that's 10 there. So the maximum height is 10 feet, but I had to get the horizontal distance by doing negative b over 2a to plug it into the equation to get the maximum height. So the maximum height is 10 feet. Okay. Notice it's a word problem related to the quadratic. It's maximum minimum. Okay, bring the page down. Number 3, a equals negative w squared plus 20w represents the area of a rectangle as a function of the width. So the area is on the left, w is on the right, so the area is a function of the width. Only the width is on the right side. The area is in square centimeters, A is the area in square centimeters, and W is the width in centimeters. What width produces the maximum area? Again, we have a vertex, and the vertex is a W and an A. That's like, again, like a Y and an X. So W and A. So I have W equals negative B over 2A. So A is negative 1, B is 20. So I have the negative of 20 over 2 times negative 1. And that gives me negative 20 over negative 2, which is 10. So when the width is 10, and again the width is in centimeters, and that's the width that gives you the maximum area. And what is the maximum area? Well, we take the equation. Area is negative W squared plus 20W, and we sub in 10 for the width. So to sub in 10, so 10 squared is 100 minus, so it's a negative 100. 20 times 10 is 200, and add, you get 100. So the area is 100 square centimeters, because area is 2 units. Okay. And number 4, a submarine's path underwater is defined by D equals 3t squared minus 60t. D is the depth in yards below the water surface, and T is the time in minutes. When will the submarine reach its lowest depth, and what is the lowest depth? Again, we have a vertex because we have talking about the lowest as the lowest is in relation to the minimum. So the vertex is T and D. This is like a Y and an X, like AX squared plus BX plus C. That's how I associate it. This is the Y and this is the X. So T is the X and D is the Y. So we have T equals negative B over 2A. So A is 3, B is negative 60. So we have the negative of a negative 60 all over 2 times 3. And that gives us 60 all over 6. And we have a 10. The time is 10 and is in minutes, so the time is 10 minutes. Okay, well, let's look at the problem in relation to working out this before I could work out the depth first. No, what I'll do is work out the depth. So D is equal to 3t squared minus 60t. So T is 10, so it's 10 squared. 60 times 10. I square first and I get 100. 600. 300 minus 600. So I get a negative 300. And again, T is in time is in minutes and the depth is in yards, so that's 300 yards. So the lowest depth is 300 yards. Let me explain it in terms of a diagram. So if you think about it, if you have the surface of the water, pretend that's waves underwater, pretend you have a submarine that's lying in the water, and the submarine is resting, so that's a 0 depth. That's when your time is 0, so this is T, and the submarine goes down in the water and then it comes back up again. So this time here, what elapses when it goes down and comes back up, and the vertex is in the middle. So what happens 10 seconds out, so as you move out here 10 minutes, so if you move out here where T is 10, you will have your vertex at 10, and the depth is negative 300. So notice the equation is a positive, and a positive means the parabola is opening down, whereas the other three that I did, it was a maximum, the parabola was opening up. Think about it. Maximum is going down, so it's opening down. And this is the minimum, so the parabola is going the other way. Positive is opening up, and then maximum is opening down. Sorry, just think straight here. So, trying to explain the problem in relation to the equation to make sure that why everything fits. So, 10 minutes down, and again, it takes 10 minutes to go down. It's going to take 10 minutes to come up. So, 10 minutes after it leaves, 20 minutes later, it'll be back up on the surface of the water again, because the vertex is in the middle. 10 is between 0 time and 20. Okay, just trying to explain the problem, because we're going to do more, and the other videos you'll have the derived equation to fill out the answers. And if you like my video, click on the like button, the subscribe button, and notification bell. Visit my math website, www.mathfullyexplained.com, to find the information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.